Our homework in Lesson 107 was to add a battery, a push button, and an SSD 1306 display to the circuit we developed in Lesson 106, turning the whole thing into a mobile measuring device. You may recall that we improved HCSR04 sensor performance in Lesson 106 when we used a state machine program to control the sensor instead of MicroPython. We also improved sensor precision and accuracy in Lesson 106 by taking multiple samples during each reading, applying a low-pass filter to the sensor data, and using a calibration curve to calculate the target distance. These techniques were carried forward to Lesson 107. However, the calibration curve calculations have been simplified and do not require Excel. The speed of sound temperature compensation used in Lesson 106 did not seem to make a significant improvement to our results, so that technique was not carried forward. The addition of a push button to our circuit allows us to operate the project in two modes: calibrate and operate. If the user holds the push button during power-up, or if the calibration parameter file is missing during power-up, the program enters calibrate mode. If the user is not holding the push button during power-up and the calibration parameter file exists, the program enters operate mode. Let's have a look at the code. Our program starts with imports as usual. We import pin because we'll be using the pin statement. We import I2C and SSD 1306 underscore I2C because we'll be using the SSD 1306 OLED display. We import RP2 because we're using a state machine. We import OS because we'll be testing if the calibration parameters file exists on the Pico W. Finally, we import time so that we can call the sleep function. Here we declare the pins that we will use for the OLED, the HCSR04 sensor, and the push button. This section of the code creates the echo and trigger objects which control the HCSR04 and the green button object. Lines 29 to 39 declare the variables used in the program. Most of the variables are self-explanatory. Calibration distance 1 and 2 are two target distances used during calibration. They represent two convenient distances from a spot on my desk to a nearby wall. You'd have to change those to suit your surroundings if you try this yourself. Lines 44 and 45 configure the OLED display. Line 50 tells the MicroPython interpreter that the following function is state machine code. Lines 55 to 71 are the same state machine code used in Lesson 106. Line 76 instantiates state machine program 0, and line 77 activates it. Here we declare the read distance function, which calls the state machine program sample size times. Each loop count is run through the low-pass filter, resulting in a filtered loop count. Uncalibrated distance is calculated using the filtered loop count and returned to the calling routine. The push button is monitored by the ISR, or interrupt service routine, declared at line 95. This is the same ISR that we've used many times. Whenever the button is truly pressed, the take a reading variable is set to true. The push button IRQ is defined on line 113. The code from line 118 to 121 clears the OLED and displays the title in the top yellow area of the display. After power on, but before execution gets to the while true loop, we capture the status of the push button. If the push button is not being held down and the calibration parameter file exists, we read the calibration parameters, message the user on the OLED, and set the mode variable to operate. Note that the progress bar in lines 138 to 143 gives the user time to read the message with confidence that the program is still running. If the push button is held down during power-up, or the calibration parameters file doesn't exist, we set the mode variable to calibrate. Here we set the previous time variables used in the ISR to the current time and enter the while true loop. If mode is set to calibrate, we prompt the user to set the sensor at a distance of calibration distance 1 from a target and then press the push button. Execution waits in the do nothing loop until the user presses the button. When the button is pushed, take a reading is set to true. Execution falls to line 162 and read distance is called. Raw distance 1 will contain the filtered but uncalibrated distance reading. We capture raw distance 2 in a similar way. We calculate the slope and intercept parameters M and B on lines 173 and 174 and store them in a CSV file on the Pico W for future reference, overwriting any previous file. We message the user. As before, a progress bar gives the user time to read the prompt with confidence that the program is still running. Finally, we switch to operate mode and the while true loop repeats. If mode is set to operate, we prompt the user to press the push button to take a measurement. Execution waits in the do nothing loop until the button is pressed, at which point uncalibrated distance is loaded from the read distance function. We use the calibration parameters in a straight line equation to calculate the calibrated distance. We display the measurement results on the OLED and the while true loop repeats. If the Pico W is plugged in, a Control C will bring the program to a graceful finish. Let's see how it works. It's difficult to get a clear recording of the OLED in a mobile project such as this, so I'll show you a variety of short clips shot on my desk. Powering up while holding the push button initiates calibration mode. The user is prompted to measure a target at 115 centimeters. Once the 115 centimeter target is read, the user is prompted to measure a target at 210 centimeters. Calibration is complete. After a brief pause, the system switches to operate mode. Assuming there's a calibration parameters file on the Pico, if you power up without touching the push button, the system goes straight into operating mode after a brief reminder how to initiate calibration mode. The system is ready to measure as soon as the reminder is finished. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.